In this video, I will be looking at the smallest grain size for the sedimentary rocks. These are the mudstones. And this is still siliciclastic sedimentary rock, so sedimentary rocks made of particles of silicate minerals. In this case, the primary ingredient are clay minerals. That's what the smallest particles typically are. There may be some quartz in here. There could be some other grains of different types, but the vast majority of these rocks is clay. And of course, that does not show up on our comparator here because we can't see clay-sized particles. And if you look very carefully at these, you really can't see any grains. Even very close up, they still look like essentially very, very tiny invisible particles. Now, some of them may feel a little bit gritty, so there might be some silt-sized particles in here. Some of them are very smooth, so that's mostly clay, but it's mostly a mixture of silt and clay-sized particles, so we just call them mudstones. So notice that all of these are in sheets, except for these two. These two are just mudstone. They're not shales. All the rest of these are shale, because remember, shale is a mudstone that breaks into thin sheets. Some of these have fossils in them. Notice these. Now, if you look very carefully, you'll see there's a leaf, there's a bit of wood, there's a bit of wood, some wood here, there's a leaf. This one has a variety of pieces of wood, as well as some leaves in there. This one has many ferns, some leaves. Look on the other side, we've got some bark here and some bark here. Many different types of stems, it looks like in this area. There's a stem, maybe some reed type things, some horsetail reed. But this side is all primarily ferns. This one here does not have any obvious fossils in it. Now, perhaps if we looked at it under, we took a thin section of it, made a microscope slide of this rock, and we looked very carefully, we might see some pieces of fossil in here, but it's not any, there are no large fossils that we can see. Same with this one. No obvious fossils, no matter where we look. This one is the same. No obvious fossils. This one has some fossils here. These are some sort of a shelly creature. So in this case, these ones are all land sediments for sure, because they've got land-derived fossils. They've got plant fossils in them. This one has some sort of a shelly creature. Most likely that is the result of being deposited in the ocean. So sometimes the best way to tell whether something is a land sediment or an ocean sediment is to look for fossils. Fossils will give you a clear indication of where it is. You're not going to find a significant amount of leaves out in the ocean. Now, of course, in the very near shore area, there might be some cases where leaves can get deposited, but out in the middle of the ocean, that's not the case. The other thing that can help us sometimes is color. Dark color is much more typical of marine sediments or ocean sediments. However, this one's clearly not marine, and it is also dark. But this one happens to be found interbedded or interlayered with coal seams. So the result of the dark color in this, just like these, is organic matter. But in this case, it's land plants instead of ocean material, ocean plankton, or any other sort of organic deposit from ocean creatures. Red usually signifies land. So this is probably more likely around a stream. This one's the ocean. This one's probably ocean. Land, 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 land. This one, because it is associated with these, this is actually part of the Catahoula Formation up in around Huntsville. These are land derived. So when we see these two in association, then we know that they're land, not ocean. If we saw this in association with this, we would be fairly certain that it is land derived. And if we saw this associated with a lovely quartz sandstone, we would be able to surmise that it is ocean derived, because we typically will see sediments in things like bays and that might be dark in color, very fine grain. And of course the quartz sandstone would be the beach deposits. So sometimes it's not just the rock individually, but an association with other rocks that gives us a clue as to where it's from. So these are the mudstones. This is how we tell them apart. As far as their origin, whether they're land or ocean sediments, we can see that some are very well layered, and if we struck it on the side with a hammer and a chisel, it would break along there. Same thing with this one. If we were to strike it with a chisel along here, we might be able to split it. This one too. There are layers in here that we could break apart. This one, however, does not have that. There are no obvious breaks in layering. Same thing with this one, it just breaks however. It is not a shale because it does not have those thin sheets. So those are the mudstones.